Hi, this is Mr. Lindemann, and I'm going to quickly show you how to calculate the number of neutrons and protons and electrons for a stable atom. And what you're going to need is the periodic table. And so let's look at just a section of the periodic table right here. In fact, let's just use vanadium. Right? So with vanadium, you can see, as there is with every element, there's two numbers. The number on top and a number underneath. Now they won't always be in those locations, but most of the time they are, depends on the periodic table. Most of the time the number at the top is the atomic number. One way you'll know if it's the atomic number is one, it's not a decimal. And two, as you go along the periodic table, you see it goes up by 1, 21, 22, 23, 24, 25, and so on. And so that is our atomic number. The other is the atomic mass, which the mass of vanadium, or the average mass of vanadium, is 50 with 942 thousandths. And so we're going to use these two numbers to figure out the number of protons, neutrons, and electrons. Now, the number of protons is really simple. If our atomic number is 23, then our number of protons is also 23. So that's easy. It tells us exactly how many protons there are. The electrons. This is also easy. Our atomic number is 23, which means we have 23 protons, which means we have 23 electrons. So these two are simple. You just look at the periodic table. Vanadium has 23 protons, 23 electrons. Chromium over here has 24 protons, 24 electrons. All right. Molybdenum has 42 protons, 42 electrons. So you see, finding protons and electrons is pretty simple. Now, what about neutrons? Neutrons, we have to do a little bit of math, a little bit of figuring, but it's not hard. It's a two-step process, and the first step is we round off the atomic mass. And so our mass here is 50.942. So we need to round this off to the nearest whole number, right? And so to do that, we have to look at the number that's just to the right of the decimal place. In this case, it's a 9. Since it's 5 or more, that means we round up, and this is going to round up to 51. So that's our first step. The second step is to subtract the atomic number from the atomic mass. So we said this, if we rounded it, was 51. I'll write it down here. And that's our rounded off mass from step 1. We're going to subtract the atomic number, which is 23. So then 51 minus 23 is 28. So that means that vanadium has 28 neutrons. That's hard to see. 28 neutrons. So you round off the atomic mass, then you subtract the atomic number, and that tells you how many neutrons. Let's look at another example. Here's another little piece of the periodic table. So if we take potassium, right, we know already, because the atomic number is 19, that potassium is going to have 19 protons. Potassium's also going to have 19 electrons. Now, to find the neutrons, remember it's the two-step process. We take the atomic mass and we round it. Now, the number just past the decimal is a 0, so we're not going to round this up. We're going to leave it like it is. So that's 39, and we're going to subtract the atomic number. So it's 39 minus 19. Well, that's 20. So potassium has 20 neutrons. All right, let's do another example. Strontium. atomic number is 38. And so that means that it has 38 protons. That also means it has 38 electrons. Now neutrons, we got to take the mass, which is down here, we're going to round it. So this is a 6. If it's 5 or higher, we round up. So 87.6 rounds up to 88. So it's 88 minus the atomic number, which is 38. And that gives us an answer of 50. And so strontium has 50 neutrons. So there you go.